Happy Monday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. So today we're going to finish up section 9.1, looking at part 2. But before we do that, do you have any questions over the homework that was over the weekend, part 1? Anybody? All right, then we'll go ahead and get started with the new stuff. So this is 9.1, part 2. All right, the first thing we're going to do is we're going to look at some functions, plug in some numbers, and evaluate the function. So for instance, f of x equals the square root of the quantity 3x plus 1. And we want to find f of 8. So f of 8 would be the square root of the quantity 3 times 8 plus 1. But recall that a radical is a grouping symbol. So we'll simplify what's inside the grouping symbol. 3 times 8 is 24. 24 plus 1 is 25. The square root of 25 is 5. So f of 8 equals 5, which would be the point on the graph, 5, 8. All right, let's take a look at the same function, but with a different value, -2. F of -2 would be the square root of 3 times -2 plus 1, which is the square root of -6 plus 1, which is the square root of -5, which is not real. Keep in mind, you can't take an even root of a negative number and get a real solution. So basically, -2 is not in the domain of this function. Any questions about that? All right. Now we're going to do one that's going to require the calculator to find the value. We have, let's see here, f of x equals the square root of the quantity x squared plus 1. F of 4 would equal the square root of 4 squared plus 1, which is the square root of 16 plus 1, which is the square root of 17. However, going to our calculator, second square root 17, it says round to the nearest 10,000th. Well, let's see here. I'm getting 4.123105626. And this is the ones, the tens, the hundred, excuse me, wrong. This is the tenths, hundredths, thousandths, 10,000ths. So basically we're rounding to 4 places. The 0 would round down. So our answer would be 4.1231 to the nearest 10,000th. Any questions about that? Okay, let's take a look at this situation. It says simplify each cube root. So what would the cube root of 1 equal? Well, the answer would be some number which times itself equals 1. What times itself equals 1? Well, 1. So the cube root of 1 is 1 because 1 cubed equals 1. Not very exciting, I know. All right, how about this one? The cube root of 8. That would equal some number, which that number times itself is 8. So what number would that be? Anybody?
That would be 2, right?
Correct. It's 2 times 2 is 4 times 2 is 8. So the cube root of 8 is 2. Great. How about the cube root of 125? Oh, wait, negative 125. Can we take an odd root of a negative number? Yes, we can. We just can't take an even root. The cube root of negative 125, well, let's see, a number times itself is negative 125. How about negative 5? Not only can we take an odd root of a negative number, we can get a negative answer. But with even roots, we can't take an even root of a negative number, and we can't get a negative answer when we take an even root. So the restrictions are on even roots, not on odd roots. Okay. How about this one? The cube root of the fraction 8/27. Well, in the numerator, the cube root of 8 is 2. In the denominator, the cube root of 27 is 3, because 2/3 times 2/3 times 2/3 equals 8/27. So it checks. Okay. How about this one? The cube root of negative 512x cubed. Well, I know it's going to be negative. What times itself is going to be negative 512? Well, let's see. 5 times 5 times 5 is 125, so it's got to be bigger than 5. How about 6? 6 times 6 times 6 is 216. Now it's got to be bigger than that. 7 times 7 times 7 is 343. 8 times 8 times 8 is 512. 8 times 8 times 8. So it would be negative 8. But what have I left out?
The x cubed?
Right. What would the cube root of x cubed be?
Just x, right?
Correct.
Yeah.
So the cube root of negative 512x cubed would be negative 8x. Let's see here. How about this one? The cube root of negative 343 a to the 6th b cubed. Well, once again, I know it's going to be negative. Let's see. What times itself is 343. Oh, it was 7 times 7 times 7. 7 times 7 times 7, 343. What would the cube root of a to the 6th be?
That would be a squared?
Correct. And what would the cube root of b to the 3rd equal?
Just b.
Correct. Good job. Good job. Let's see. How about this one? Let's see if this is going to transfer okay. We'll find out here in a minute. Close this up and open this one. All right, can you see my graphing screen? Great. Let's change this to black. All right. And we'll come up here, here. Okay. It says complete each table and graph the function. And the function is f of x equals the cube root of x minus 3. And the table has the following x values: -8, -1, 0, 1, and 8. Why do you think they chose those specific x values? What's true about all of those x values?
They are,
Go ahead.
they're cubes, right?
They're perfect cubes. So let's take -8. F of -8 would be the cube root of -8 minus 3, which is -2 minus 3, which is -5. Okay, let's see. -8, -5 would be right here. -1. F of -1 equals the cube root of -1 minus 3. The cube root of -1 would be -1, because -1 times -1 times -1 is -1. So that's going to be -4. X is -1. Y is -4. 0. F of 0 equals the cube root of 0 minus 3. Well, the cube root of 0 is 0, and 0 minus 3 is -3. Okay. F of 1 would be the cube root of 1 minus 3. Well, the cube root of 1 is +1. Minus 3 would be -2. And finally, f of 8 would be the cube root of 8 minus 3, which is 2 minus 3, or -1. So we get a graph of that. Let's see if I can get a good picture of that.
Wouldn't the cube root of 1 be -1 because it's 1 times 1 times 1? Or am I wrong?
Okay, let's hear what you just said. You said, would the cube root of 1 equal -1? Is that what you said?
Yeah.
And then you said because 1 times 1 times 1 is 1.
Oh, wait. I was thinking of cubed. Sorry. Never mind. Yeah,
the
because
-1, the quantity cube would still be -1. Yeah.
Yeah, that's what I was.
Okay. All right. We're good. Let's see here if I can get a decent drawing of this graph. Okay. And then this is going to head off. Yeah, that's going to head off. So there's the graph of the cube root of x minus 3. Any questions about that?
So we just have to use those numbers in order to get that, right?
Mm-hmm. They gave us these inputs, so you plug those in here to get their respective outputs, and then graph it using that. What's the domain of this function? What can I put in here? Can I put in positive numbers? Can I take the cube root of a positive number, of any positive number?
From what I can understand, it can be any number positive of the positive, right?
Yep. How about negative? Can I take the cube root of any negative number?
According to the line, it looks like.
And how about 0? Can I take the cube root of 0? I did right there.
Yes.
So what's the domain? All real numbers.
Yeah.
Okay, excellent. Let's see here. Now we're going to graph. Let's see. Let's go to the next page.
Mr. Mayo,
Yeah,
one question. Will they give us a number in the X value that isn't a perfect cube ever?
they could, and then they would ask for like a decimal approximation, which you'd use your calculator for.
I see.
So that could happen. Let's see here. Look and see if there's any examples in the book that are like that. Yeah, here, let's go back. Let's take a look at this and then we'll go on to some more graphing. It says g of x equals the cube root of the quantity x squared plus 1. And they want g of 6. So we get the cube root of 6 squared plus 1, which is the cube root of 36 plus 1, which is the cube root of 37. Okay. So now, how do you find a cube root? I'm glad you brought that up because I had overlooked it. On your calculator, there should be a button that looks like that, where there's no index written. So the implied index is a 2. That's not going to help us for cube roots. But there should also be a button that has this, but if you look very carefully, the index is an X. So what I need to do is I need to put a 3 in the index. Typically, the way these calculators work is with the calculator completely cleared, you type in the number that you want to be the index. So I'm talking about a TI 30 Roman numeral 2 S or B that was recommended for this course. You type in the index, then if this is a second function key, you push the second function, and then you push that button. Then parentheses, let's see, then you put in 37, close it up, and push equals. So let's see what we get if we do that. Okay. So, 37, not 27. I'm coming up with 3.33221852. Rounding to the nearest 10,000th, it would be right there. So you'd get approximately 3.3322. So you need to use the Xth root button. But again, the way you use that is you put the index in first. Now, you could use that as a square root button, just putting an index of a 2 in, but that's more work than just using the square root button in the first place. You okay with that, Abel?
Yeah. My calculator doesn't seem to have that option though, so.
What? Okay, what is your calculator?
I use the calculator I have on my computer, and it's got a scientific function on it. So I could definitely see the square root, but I don't see any symbol related to what you told me.
What you might do is, not right now, but do this later, and then if you have questions, let me know. Go online, type in scientific calculator.
Yeah, I think I'll do that until I get an actual calculator.
Yeah, you should be able to find one that has an X root. There's another way of doing it, but we aren't there yet. And I don't want to open that can of worms quite yet. Okay, so let's go back and look at some more graphing problems. Let's see. Here we go. This says graph the function, and it says f of x is the cube root of x minus 3. Now, let's go back to the one here. This is the cube root of x, but the minus 3 is outside the radical. This is the cube root of x minus 3, so that whole thing is inside the radical, okay? Now, let's go back. Here, because inside the radical, the cube root was x, we used x values that were cubes. -8, -1, 0, 1, and 8, okay? Here, if I use those same x values and plug them in here, I'm not going to get cubes, am I? Because -8 is going to go here. The next thing I'm going to do is subtract 3, and it's going to be -11, which is not a cube. So what could I do? What actual values could I choose here so that that x minus 3 is a cube? Well, if once I put this number in there, the next thing I'm going to do is subtract 3. What if I took this number and added 3 to it? So what's -8 plus 3?
I'm sorry, you're asking plus 3?
Yes, what's -8 plus 3?
That would be -5, wouldn't it?
Okay, if I put -5 in there, I'll get -2, all right?
Uh-huh.
So what I want to do is I want to take these values plus 3. -1 plus 3 is 2. 0 plus 3 is 3. 1 plus 3 is 4. 8 plus 3 is 11. Why add 3 before I put it into the function? Because as soon as I put it into the function, the first thing that's going to happen is we're going to subtract 3. That'll take it back down to these numbers and give me cubes.
So how do we know when we have to do this then?
Well, if it's the cube root of x, then you put in cubes, but this is x minus 3. So I'm going to add 3 to a perfect cube so that when I put it in there, I subtract 3 and it becomes a perfect cube. You're undoing what's going on inside there. Now, would you have to do that? No, but if you do that, you're going to get nice numbers. And to graph the function, I'd rather have nice numbers than have to go through and use that X root button and approximate all those numbers. So this is going to give me, let's see here, 2 minus 3 is -1. The cube root of -1 is -1. 3 minus 3 is 0. The cube root of 0 is 0. 4 minus 3 is 1. The cube root of 1 is 1. 11 minus 3 is 8. The cube root of 8 is 2. So I'm compensating for the fact that I'm going to subtract 3. What if this had been x plus 3? Then I would have taken these values and subtracted 3 from it so that when I put it inside and added 3, it'll take me back to perfect cubes. So you're undoing what's happening there. I don't know if that makes any sense. Okay, -5, -2, 2, -1, 3, 0, 4, 1, and 11. All right, 11, 2. Yeah. So let's see what my picture looks like here. Trying to get a good picture from, I've got this curve that I'm using. Maybe, maybe not. Wish you could see what I'm working with here. I've got this. Let's see. There we go. Just trying to make a more accurate drawing than just doing it totally freehand. Maybe I should have just stuck with totally freehand. That looks a lot like that other one, doesn't it? Let's see here. Yeah, see there? Very similar, isn't it? Okay, any questions on that one? What's the domain of this thing?
It looks like all real numbers to me.
And it is. What's the range of this thing?
From how you drew it, it looks like all real numbers again.
Yep, that is correct. Okay. Let's see here. This says, evaluate each radical expression if possible without using a calculator. And let's go back to our other board here. And change the sharing. Okay. How about the fourth root of 81? So now we're looking for a number where that number times itself is 81. Well, what's 1 times 1 times 1 times 1? That's 1. How about 2 times 2 times 2 times 2? 2 times 2 is 4, times 2 is 8, times 2 is 16. How about 3? What's 3 times 3? Nobody knows what
3 times 3, that would be 9.
times another 3.
That would be 81. No, wait, 27.
Times a fourth 3. There's your 81. Yeah, so fourth root of 81 is 3. How about the fourth root of negative 81? Would that be negative 3?
No.
It would be not real because you can't take an even root of a negative number. Okay. How about this one? The fifth root of negative 243. Can you take a fifth root of a negative number?
Yes.
And you're going to get a negative answer. But what number is that going to be? Well, let's see. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, so it's bigger than 2. Well, 3 to the fourth power was 81, so 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243, so it would be negative 3. What's another way you could do this problem? Well, back to your calculator using the xth root button, you'd put in a 5, second function key, xth root, parentheses, negative, not the subtraction sign, but the negative sign, 243, close it up, equals, and you should get negative 3. Again, if you've got a calculator that has that on it. All right with that? How about this? The fifth root of negative 1 over 32. Can we take the fifth root of negative 1 over 32? Can we take an odd root of a negative number? Yes.
Yeah,
What's the fifth root of -1?
that would be 1, -1. wouldn't it?
-1. What's the fifth root of 32?
Good question.
Well, think it through without a calculator. 1 times 1 times 1 times 1 times 1, not big enough. How about 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Ah. So the fifth root of 32 is 2, so that goes in the denominator. All right. Now for some fun, we're going to go back to looking at some of those absolute value situations we did over the weekend. Simplify each radical expression. Assume all variables are unrestricted. So the variables can be positive or negative or 0. Okay. How about the fifth root of 32a to the fifth power? Well, we just did the fifth root of 32. What was that?
Oh, that would be 2.
How about the fifth root of a to the fifth?
That would be A.
Do I need absolute value bars?
I don't think so.
Nope. If you're taking an odd root, you can get a negative answer. So no restrictions there. How about this one? The fourth root of 81a to the fourth. What's the fourth root of 81?
It was 3, right?
Yep, still is. What's the fourth root of a to the fourth?
That would be A.
Do I need absolute value bars around the a?
I don't think so.
Yes, I do.
Oh,
Because I'm taking an even root. A could be negative, but we've got to make it positive.
well, it could be positive or negative.
Right. But if it's negative, we can't, then we'd be getting a negative answer when we took an even root, and we can't have that.
I'm sorry you lost me there. What?
Okay. Okay. Set up front, there were no, the variables were unrestricted. So a can be positive or negative. If that's true, then just plain old a could be negative, and 3 times negative would be negative. Since we're taking an even root, we can't get a negative answer. So we've got to put absolute value bars on it to assure us that it's not negative.
Okay.
Same stuff we did over the weekend, going back to the previous part of section 9.1. How about this one? Let's see here. The sixth root of k to the 12th power. What times itself, times itself, times itself, times itself, times itself would be k to the 12th? What would the exponent be?
That would be K squared, right?
Okay. Do I need absolute value bars around k squared?
Looks like. Or
I don't, because if k is negative, but it's being squared, it's still going to be positive. So this is never
Right.
going to be negative. I know, I know. How about this?
it's going to take some time to wrap my mind around that.
Yep, I get it. How about the sixth root of k to the 6th? What's that going to be?
That would just be K.
Do we need absolute value bars there?
Don't think so.
But I do, because k could be negative.
Yeah.
You might want to go back and look at the first part of this section again.
Yeah, I'm going to have to.
Yeah, because it's, how about this? The fourth root of x minus 7 to the 8th power. So this is going to be x minus 7 to what power?
to the second power.
So do we need absolute value bars there?
Can you put absolute value bars around parentheses?
Well, you can, but if it doesn't need them, you shouldn't put them there.
I
Is
don't think
this-
it needs them.
It doesn't need them because if it's squared, it's never going to be negative.
Oh, I see now.
Okay, we're getting there. How about this?
That would just be x minus 7, right?
Do I need absolute value bars there?
Yes.
There you go. You're catching on. You're getting back in the saddle. Okay. Let's see here. How about this one? The cube root of 1,000, a to the 6th, b to the 6th. What's the cube root of 1,000? What times itself is 1,000?
That's a good question.
10. 10 times 10 is 100 times 10 is 1,000.
I should have seen that.
That's okay. What's the cube root of a to the 6th?
That'd be a squared.
Cube root of b to the 6th?
Squared.
Do I need
Squared.
absolute value bars or anything there?
I don't think so, except for no, I don't think so.
Okay, good. How about this one? What's the cube root of 1,000?
10.
Cube root of a to the 6th?
A squared,
Cube root of b cubed?
b.
Do I need absolute value bars here?
Around the b, I think.
Good. Good. Now we're getting somewhere. Okay. How about this? What's the square root of 64?
That's 8, right?
Good. What's the cube root of 64?
I don't know.
4. 4 times 4 is 16 times 4 is 64.
Uh-huh.
What's the square root of negative 64?
4 or negative 4.
Not real. You can't take an even root of a negative number.
Oh.
Okay,
I thought you said cube. Never mind.
okay, all right. What's the cube root of negative 64?
Negative 4.
There you go.
Got ahead of myself.
That's okay. That's okay. All right. So tonight, wrap up section 9.1. And something I didn't mention last week, tomorrow is advising day. There will be no class meetings tomorrow, at least not my math class, no office hour. Tomorrow you should get in touch with your advisor and see about registering for class for next quarter. Okay, so no class, no office hour tomorrow. I will be back today at 1:15 for my office hour, but other than that, won't be back again till Wednesday. Any questions about that? All righty,
No.
I'll stop the recording.